in these test tubes, I have some calcium carbonate. So, calcium carbonate powder, calcium carbonate pieces, calcium carbonate powder, calcium carbonate powder. So, every test tube contains the same substance. Now, I want us to look at factors that are going to affect the rate of reactions. So first of all, I've got some dilute acid, dilute hydrochloric acid, and I've got some concentrated hydrochloric acid. So I'll try that first in the first two test tubes. So first of all, a little bit of dilute. Put some dilute in this beaker. And some concentrated acid in this beaker. I don't know if you can see there because I'm standing in front of everything. Okay. So it's the same substance. This one's just got more water mixed with the HCl. Okay. This could be a bit messy. Okay. So let's see. So which factor are we investigating here? The concentration of the reagent. Now, to mention it, I cannot. Solid doesn't have a concentration. It's got a concentration, but it's a constant concentration, because if the mass of the solid decreases, so will its volume, so the moles over volume will stay the same. So here, only the acid's concentration is the changeable one. Right, let's see how it will go. Now you can't say. Okay, so which one bubbled up more? The concentrated one. So, asseblief. Asseblief. No. Okay, so what I need to do to neutralize that acid is I'll need to put some more sodium calcium carbonate onto it. Okay.
Why are you putting it on the floor?
Because I've spilled this acid spilled on the wood, and I don't want everything to be destroyed. So, the higher the concentration of one of the reactants or reagents, the faster the reaction will be. You got it? So, the higher the concentration, the faster the rate of the reaction. Here, I've got some chunks of calcium carbonate, and I don't want to do it with the concentrated, and before I've tried it with the dilute acid. So here we go, dilute acid. I think this dilute acid is not as diluted as I thought it would be. So you remember how fast it was in this test tube, the dilute acid? So here we can see that the chunks of calcium carbonate reacts much slower than the powder of the calcium carbonate powder. Yes?
Is it because of its surface area?
Yes. The powder has a very big surface area. You can spread a powder out and it can cover a large area. You understand what I'm trying to say? Yes. Or we could say the state of division. The powder has a higher state of division, so it's got a higher surface area, so the acid can get to more of the calcium carbonate particles in the same time. So the reaction is faster with the powder than with the chunks.
No?
Yes.
In the diluted HCl, is it like little
hydrochloric acid, less hydrochloric acid. We'll go through the explanations.
For example, would a possible reason for the
powder reacting quicker with the
Acid.
than the chunks, is because like the particles are more like loosened together.
Yes, they're loose, they're free, they can touch. The acid touches it faster.
Oh yeah.
Where the chunks have, it's only on the surface of the chunk that acid can attack the calcium carbonate. So it's got less space to touch the calcium carbonate, to collide with the acid, between the calcium carbonate and the acid. Okay, so the first one was the difference in concentration. The second one was the difference in the state of division. Now I can't remember why I've got another one here. I remember. I bought the kettle.
Boiled water.
I bought the kettle. That's why. So here I've got some really very hot water. And do you think this reaction is still taking place?
Yes. Yes, it is.
Yes, it is. There are still some bubbles forming. Let's see if we can change the speed of the reaction by placing it into warm water.
The warm water serves as absorption.
Pardon? Yeah, look there. It's boiling much faster. Now you can't see it on the video,
Can all see those.
but you can hear it and you can see it. It's boiling much faster in the warmer water. When you heat up the acid, the water is heating up the acid. So the acid now, with a low concentration, the acid now is warming up. So now the particles have higher kinetic energy.
The temperature of the particles can be the next factor.
Yes, the third factor is the temperature of the particles. So it's concentration, state of division, and temperature. Now there's a reason why I used the same chemicals, the hydrochloric acid and the calcium carbonate. There's a reason why I use it, because those particles have a specific nature. Okay, so the fourth factor that affects the rate of a reaction is the nature of the reacting substances. Now I'm taking you back to grade 10, when we had, you remember the solubility rules? I wasn't really supposed to teach you, but I did because I knew it came up. It's sneaky. So here I've got some sodium chloride and some silver nitrate. Okay, let's see what happens in that. Okay, this one will carry on for quite some time. It's not producing anything with smells, it's just making carbon dioxide. Okay, and by the way, this boiling up reaction, this foamy reaction is called effervescence. Nice. So I'm going to work in this test tube now, and what I'm going to do is I'm going to place some silver nitrate into this test tube, and all nitrates are soluble, so silver nitrate is in a solution like that, soluble, and I'm going to add to that some sodium chloride. The reaction is instantaneous. The reaction is instantaneous. It happens immediately because of the state of division, but also the nature of the reacting substances. The moment the ions from this solution gets in contact with the ions from the other solution, that moment the reaction takes place. Okay. Now, something about measuring the rate of the reaction. In this one, because a solid is formed, when the ions of silver and chlorine comes together, the electrolyte will change. The conductivity of the solution will change immediately. So you could have a machine that measures the electric conductivity of the solutions before they're added, and then take that one solution and add it to the other, and because ions are removed from the solution, the conductivity of the solution will change. So that is one way of measuring the rate of a reaction. Now with this one, you can measure the rate of the change in mass, or, and we're going to do it here, we can measure the volume that is formed. So I'm going to, you happy with that?
Amen.
So the 4 factors: concentration, state of division, temperature, and nature of the reacting substances.
Amen. Is removing the ions going to increase or decrease
Is removing the?
the ions going to increase the conductivity?
No, if you remove ions from the electrolyte, it will decrease the conductivity. Okay.
Then is it the 4 factors to the reaction?
Yes, the 4 factors.